Hello everybody, welcome to my course Reactive Intermediates, Carbenes and Nitrines. So far we have discussed various aspects of nitrines, as per example how you can generate them, what is their electronic structure and what will be their different type of reactions. Among that we have already studied that addition reactions from nitrines. So, today we will learn about the insertion reactions of nitrines. Okay. So, what we will learn today, that is called of nitrines. As we already know that the nitrines are also similar like carbenes, they are also electron deficient species and they are also wants to have various type of electrons to fill up their octets. So, that is why these insertion reactions are very much common with these nitrines. Okay. And why it is important these insertion reactions? Because the generation of carbon nitrogen bond via carbon hydrogen bond functionalization is very important topic, because in this way we can actually make various type of pharmaceutically active or bioactive compounds. Okay. So, for that reasons to make these type of carbon nitrogen bonds in a step economic way, these reactions are very important, because in this case you can take some unactivated carbon hydrogen bonds and there you can insert this electron deficient nitrine species. Okay. So, this way what we can see that as per example, if you take this cyclohexane, these are having carbon hydrogen bonds, and now if you use this azide, then under thermal or photochemical condition this can generate this carbon nitrogen bond. If you see here, this carbon hydrogen bond in between this one, this carbon nitrogen bond has formed. Okay. So, basically it got inserted into that. Now, what kind of nitrines that will give facile reactions for amination or rather carbon nitrogen bond formation reactions. As per example, if R equals to acyl sulfonyl or cyano, they give very facile reactions, rather the insertions of these nitrines are very facile to generate the desired product. However, when this is alkyl group, there is lot of side products formations due to the 1 to hydrogen shift. Okay. So, the overall yield of the desired product will be very poor. Okay. And what happens when this is aryl ring? That time most of the cases the end product forms that aniline type of derivatives. Why? Because once this aryl nitrine will generate, that will abstract hydrogen and that will give you the aniline derivatives. Okay. So, these are the different type of aspects for various type of nitrines. And in terms of selectivity, of insertion by these nitrine reactive intermediates, that always guided by the different type of carbon hydrogen bonds. As per example, if some compound like 2 methyl butene, okay, So, they will have 3 degree, 2 degree or 1 degree, that means tertiary, secondary or primary carbon hydrogen bonds. Okay. Now, nitrines are having specific target, that means nitrines will first prefer to insert into tertiary group, this one, then this will insert into this, then this will insert into primary. That means, their affinity towards this tertiary carbon hydrogen bonds. It will selectively first go to tertiary carbon hydrogen bond, then secondary carbon hydrogen bond, then primary carbon hydrogen bond. Okay. So, the selectivity patterns in general follows. So, selectivity patterns okay, follows this type of reactivity. That is the tertiary, then secondary, then primary. Okay. So, in that way, if you take any molecules which are having different type of carbon hydrogen bonds, and their bond dissociation energies are different for those type of carbon hydrogen bonds, in that cases the nitrines that will be inserted into those carbon hydrogen bonds in a different selectivity. First it will go to the tertiary one, then secondary one, then primary one. And when we will see the nature of these nitrines, that means, we found that there are two type of nitrines can be possible. One is called singlet, another is called triplet, right. So, in case of singlet nitrine, they are in general they are inserted into these carbon hydrogen bonds. Okay. So, what happen? Mostly these singlet nitrines, they insert into the unactivated carbon hydrogen bonds. Okay. Once they will get inserted, then only this carbon nitrogen bond will form. And as this is a singlet nitrine, most of the cases these reactions are highly stereospecific, rather all these singlet nitrines, they are inserting into the carbon hydrogen bonds in a concerted manner. Okay. That means, definitely they will be, the reactions will be highly stereospecific, and obviously the retention of configurations. Okay. So, what we can say, that insertion is highly stereospecific and number 2 is that these reactions, they will be giving the retention of configuration, okay, or that means that retention of, you can write in this way, retention of configuration. Okay. And in case of triplet, what it is found, that in case of triplets generally this insertion is low yielding, okay, and they are non stereospecific addition, sorry, non stereospecific insertion. Okay. So, these are the different type of reactivity for different nitrines. Fine. Now, if we see what I said here, as per example, if we take trans 1,2 dimethyl cyclohexane, okay, then if we treat it with nitrene, what it will generate? It will generate the this if it is a singlet nitrene, if it generates singlet nitrene, okay, then obviously the insertion of this nitrene, okay, will be stereospecific manner and it will be in a concerted way. Okay. Now, we have seen that in case of singlet nitrene the insertion is in concerted manner, and definitely in case of triplet nitrenes we have seen that triplet nitrenes are behaving like a diradical way. So, in that case we have we can say that reactions will go in a stepwise manner. As for example, if we take this singlet nitrene, okay, then the mechanism we can think in this way that we can put here R. Okay. The insertion mechanism will follow through this transition state, okay, and okay, through this concerted manner. Okay. Finally, the insertion will happen and it will give the inserted product. Or we can give there R prime, here R prime. Okay. So, here R prime. Okay. So, this way actually singlet nitrene got inserted into the carbon hydrogen bond. What will happen if it is a triplet carbene? This is triplet nitrene. Okay. Now, in similar fashion this can react with carbon hydrogen bond, but the mechanism will be different. They can also got inserted even though lot of cases the yield is poor, but what it will give in a finally, this will form this carbon nitrogen bond. Okay. So, this is some kind of stepwise. So, these are the two overall mechanisms for these nitrene insertions. Okay. So, one case definitely the retention of configuration or it will be highly stereospecific reactions, whereas in another case as for example, for triplet case definitely the non stereospecific reactions or non stereospecific insertions of this nitrene species will occur. Okay. Next what we will see? Next we will see that some examples. We have seen that if we take aryl nitrene as per example, okay, for intermolecular, as we have told that for this intermolecular CH insertions we have seen that aryl nitrene for intermolecular CH insertion generally gives poor yield. Okay. What we have seen, when this, in spite of aryl nitrile, if you take sulfonyl, acyl or cyano group, then this type of insertions will give better yield. Okay. But if we take its intramolecular version, intramolecular CH insertion, then it gives good yield with retention of configurations. Okay. So, what it will get? You will get good yield of product with retention of configurations. If we see some examples as like this way. So, as per example, if we take this substrate where we have some stereogenic center and we have aryl azide as a aryl nitrine precursor. Now, if we heat it, it will give the desired product with retention of configuration. Okay. This is important in a 50 to 60% yield. Okay. So, if we see here, this is important here, retention of configuration. Okay. So, we have seen that when this intramolecular fashion of this CH insertion is happening for aryl nitrine, we are getting good yield of product with retention of configurations. Okay. And this is actually the one of the examples where intramolecular insertion is happening to the aliphatic carbon hydrogen bond. Okay. So, what is happening here? So, the intramolecular CH insertion in aliphatic carbon hydrogen bond. Okay. Now, we will see some intramolecular insertions of nitrine into aromatic carbon hydrogen bond. As per example, if we take these substrates, this biaryl nitrine Okay. In that case, now this can react in this way and will give this intermediate, sorry, not so this stepwise way, this is actually happening. Okay. Now, so finally, it will give you very important aja heterocycles, that is called carbazole. Okay. So, here what is happening? First is this electrocyclization, okay, and followed by the 1,5 hydrogen shift. 1, 2, 3, 4, 5. So, electrocyclizations followed by 1,5 hydrogen shift. Okay. In similar fashion, if we take another example, this one, this vinyl nitrene, okay, and this can come from some azidocinamates. Similarly, here also it can come from this biaryl azide. Okay. Here it is azidocinamates. Okay. So, in this case what it will give? It will also go in a similar mode of this electrocyclizations followed by 1,5 hydrogen shift, and in that case first it will again it will give okay, and then 1,5 hydrogen shift to provide okay. So, these reactions also following the similar mode of pathway. Okay. Similar way it is also as per previous way, this is also working in similar way. Okay. Now, so however, this we can give one example, this is intramolecular insertion into aromatic carbon hydrogen bonds. Okay. So, we have seen initially the intramolecular insertions into aliphatic carbon hydrogen bond, here it is going through intramolecular insertions into aromatic carbon hydrogen bond. Next we will see some aminations, carbon hydrogen bond aminations through intra versus this will work in intramolecular way, but in different regioselective manner. That means, as per example, in a molecules if there is two possible centers are there where this carbon nitrogen bond can form, that means insertions can happen, in that case how that will react. So, if we see this compound, this sulfonamide as the precursor for this electron deficient species, it will generate the metallonitrenes. As per example here, we take some rhodium 2 catalyst and some oxidant, hypervalent iodine based oxidant, okay. So, this is the pivalate group PHIO pivalate hold 2, that will give first what it will generate. These things actually will generate some iminoiodine like this. Okay. So, I am not writing whole things, okay. And then in presence of rhodium 2 catalyst, this will give you the metallonitrines or nitrenoids. Okay. So, once it will generate, then now this electron deficient species can be inserted into two possible way here. As per example, here this place it can be inserted. If you see here that total ring member, it will be like a 6 member ring and it can be inserted here also. Okay. This is in this case this is 3 degree tertiary carbon, and in this case this is the benzylic position. So, now we have to see that in which one or in which carbon hydrogen bond it will be inserted more, and in which carbon hydrogen bond it will be inserted less. So, if you see the mechanistic way to get inserted into a carbon hydrogen bond for this nitrenoid species, then we can tell so this is the this nitrenoid species. Okay. Now, have these carbon hydrogen bonds that can be get inserted through this, okay. And okay. Then similar way it can be inserted into this place also, this benzylic place also. I am not showing the both, but now this is the concerted carbon hydrogen insertion of metallonitrene or nitrenoids. Concerted, we can write it concerted insertion. Okay. Once this will happens, it can happens in similar fashion to here also. Okay. I am not showing that, but overall the product will be we can write in this way that there are two products will form. First, this will give the insertion into the tertiary carbon, and okay. Fine. So, this will be this product, plus what will happen, the insertions can happen in different benzylic place, okay. And the ratio between these two products will be 7:1. Okay. Why? Because it has been found that carbon hydrogen bond reactivity for this intramolecular oxidations, the qualitative rate, as per example, it has been found that it is like 3 degree, then the alpha ethyl, then the for benzylic, okay, then secondary, and then for primary. Okay. So, here we have seen as per the reactivity rate for this oxidation, there what it has been found for this tertiary carbon, that is getting faster reactivity than the benzylic. So, that is why here the reduced selectivity happens in this way, that carbon nitrogen bond formations occurs mostly in major product this one, and then the minor product is this one. Okay. Thank you.